Hey everyone, let's talk about today's LeetCode daily challenge. This is an interesting problem. I liked it. It's also a little similar to yesterday's problem. I mean, in context, both of them are related to strings and anagrams. Let's see how. So two strings are considered close if you can attain one from other using the following operations. Okay, so operation one is that you can swap any two existing characters, like any two of them. Any two of them. We'll see why this is important. Operation 2, transform every occurrence of one existing character into another existing character and do the same with the other character. So this is an example. So we choose A and B and we turn all of the A's to B and we turn all of the B's to A. You can use the operations on either string as many times as necessary. And we are giving two strings and we want to see if they are close or not. Let's take a look at a very simple example. Let's say the two strings have the same exact characters. Can we convert one string into the other? Let me give you an example. So let's say we have A, B, C, and D. We have this string, and we want to convert this to D, A, B, and C, right? We want to convert this to this. We're going to call this S and call this T, a string S and a string T. Let's see whether this is possible or not. And I'm guessing that the first operation should be enough, right? Because the second operation is telling us, hey, you can transform the occurrence of one character into the other. In this example, we don't need that. We just need to do as many swaps as possible to turn one of the strings into the other string. So let's see where A should go. A should go, let me have a copy of this string here. So we keep the original one, A, B, C, D. In order for A, B, C, D to become D, A, B, C, what should happen? A should go to this place, B should go to this place, and C should go to this place, and D should go here. You see? So if A goes here, A is in the second place. B goes here, then B would be in its place. If C goes to the last character, then C is in place. And if D goes here, D is in its last, in the first position. So let's start swapping. Let's start doing that. Like, let's send A to where it should be. So this will become this will become B, A, C, D, right? Now we have a character that is fixed. So A is where it should be. Here, you see, A is where it should be. We have B, C, D that are not where they should be yet. So B should go to here, because B is in the third position. C should go to the last position, and D should go to the beginning. So now you see, from a cycle of length 4, this is a cycle. We have a cycle of length 3 because we could swap two of them. If we do another swaps, like B goes to this place, let's see how this happens. So what happens if we do this? So B goes to B and C swap their places. So C, A, B, and D, right? So now which two characters are in their final places? A and B. You see, A and B. So we have C and D. So now C should go to the last position and D should come to the first position. And here we have a cycle of length 2, right? we did another swap, and now we have a cycle of length 2. If we do another swap, we will have the final string. So if we swap C and D, we will have D, A, B, and C. And now you see that with the last swap, all of them are in their own place, D, A, B, and C, as you can see here. So you can prove that given any string, you can turn that string into any other permutation of that string with operation 1. So what we need to do is so if you have like S, so let me just write this. If S and T are permutations of each other, we can convert one to the other just by swapping. And the idea is that if you generate this graph to see where should this letter go, 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 you will have some disjoint cycles. Let me just give you another example. I'm not gonna do it. I just want to give you another example. So A, B, C, and G, H. So if we want to convert this to the other one, A, B, C, H, G. So where should A go in this example? A, if we want to convert this to this. So A should go here, B should go here, and C should go here. You see we have a cycle of length 3, and then G should go here, and H should go here. So we have if we have disjoint cycles, and disjoint cycles can you can decrease their length if you keep swapping, just like this example. So the length is going to decrease, and at the end of the day, you will have something that there are no cycles. That means you have the final answer. So now we know in order to convert one string into the other, we should make the two anagrams. So if we make the two strings anagram of each other, then doing the final swapping is possible, because we just proved that it's possible to convert any anagram to its other anagram or permutation. Okay, so now we should see if we can make a string A an anagram of a string B. So let's go and see another example. So in this example, because when you are working with anagrams, I also mentioned this yesterday, when you are working with anagrams, just think about the frequency of each letter. So let's say we have two A's and 3 B's and 4 C. Okay, and on the other side we have 4A, we have for example 2B, and we have 3C. So what we have here is that now if you see something great should pop up here, and you'll notice something, that the letters are exactly the same. So this is required. This is the condition that is necessary for the problem to have answers. So the letters that we have, let's forget about the frequency of the letters, but the letters itself should be the same. That is necessary. Then you should look that, oh, the frequencies should be a permutation of each other. So if you look at this, so we have 2, 3, 4. So we have 2, 3, 4 should become 4. This should become 4, 2, 3. And we just proved that if we swap two frequencies with each other, we can convert any one to the other. So in order to make this the other one, 2 should go here, 3 should go here, and 4 should go here. If we do this, we can convert this one to this one. And that's it. Yeah. So the letters should be the same, and also the frequencies should be anagrams of each other. So for example, if you have let me give you another example what I mean by anagram. So if you have 2A, 2B, and 3C, and 4D. This is the first string. This is S, right? And for T, let's say we have 4A and 2B and 2C and 3D. So you see that the letters are the same, A, B, C, D, A, B, C, D, and the frequencies are the same. Are anagrams of each other, sorry. So here we have 2, 2, 3, 4, and here we also have 4, 2, 2, 3. In order to check if two vectors are anagram of each other, you can sort them. So this is already sorted. You can sort them and then compare them. So this should become 2, 2, 3, 4. So this is a very, very classic way of very common way of comparing if two vectors, if two strings are anagrams of each other. You sort both of them and then you compare them. If they are equal, that means they are anagrams. You do the same with these letters. You sort them and you see if they are equal. So ABCD here and here ABCD. They are equal. So that is the condition that we need to check. Let me give you another example why we need the set of letters to be equal. So let's say you have 2A, 2B, and 3C, and 4D. This is a string S. This is a string S. We said that we work with the frequency of the letters when we are solving an anagram problem. So here we have 2A, we have 2B, we have 4G, and we have 3C. So the set of letters are different. And if you go back to the problem, we can just transform every occurrence of one existing character. So the character should already exist in order for us to transform it into another existing one. So we don't have G here. We don't have, this should be H or C, it doesn't matter. But anyway, we don't have G here. We don't have H here. So we cannot transform C to G or D to H or vice versa. So this is the necessary condition. Let's go and see how we can write the code for this. I'm gonna keep this. Yeah, I'm gonna keep this page on. So we will refer to that, how we want to how we want to write the code. So we need the frequency. So I'm gonna call this S and T. So I need a frequency table for both of them. So auto sFrec equals get frec s. So I used a similar function yesterday for yesterday's problem. You can take a look at that. Tfrec equals get frec t. And now we want the keys to be equal. So we want the keys to be equal. So I need another function that gives me the keys in sorted order. So auto s keys equals get keys in sorted order as frick. And I copy that. I need t keys. So this is going to be t frick. Then I need to get this is the keys. So this is the A, B, C, D. And I also need the frequencies. So these are the values of my dictionary. So my dictionary is from letters to integers. So I say from A, I have 2. From B, I have 2. From C, I have 3. From D, I have 4. This is my dictionary. And this is the frequency. This is the dictionary. And then I have auto s values equals get values in sorted order s frick. So I give the dictionary and I ask for the values in sorted order. And this is t values, get values in sorted order t frick. And the condition for us to return true was the keys should be equal and the values should be equal. And because they are already in sorted order, I just do that. So return s keys equal t keys and s values equal t values. That's it. And then I need to define this function. So map char int string s map char int frick for char c s frick of c++ and return frick. That's it. I need the keys in sorted order. So vector of char map of char and int frick. So I need to iterate over this map. So for const auto pair frick. Okay. And I need a vector of char result or keys. Keys that push back pair dot first. Oh, sorry. And yeah, I just sorted sort keys dot begin, keys dot end, and return keys. And I need to implement the same for values. So vector int get values in sorted order. So values and values push back pair dot second. And then I sort values and I return values. So let's run. Okay, values, vector. Oh, this should be a vector of int. Copy and paste problem. Sorry. All right, and let's submit. Good. I'm going to come up with some variation of this problem in a few seconds. I have two simple variations about this problem. Let me tell you about them. Let's say you have two strings s and t, and you know s and t are anagrams, and both of them are consisted of unique characters, unique letters. What's the minimum number of swaps? The minimum number of swaps to convert S to T. How do we do that with minimum number of swaps? I'm with this, I'm referring to the operation 1. You can do as many, not as many, do as minimum of the operation 1 as possible to convert S to T. This is, again, a classic problem. Instead of S and T with unique letters, you can have permutations of the numbers from 1 to N. That is the same question. And for the second question, for the second variation, actually, I want to get rid of this condition. If we can transform every occurrence of one existing character into another character, it shouldn't necessarily be existing. How does the solution change? So we don't care about this. If we don't care about the other character to be existing, how does your solution change? We discussed this in our solution. Actually, this makes the problem easier. But how? Thank you.